Dr. Atulkumar Manchelwar sir is with us now. I welcome you, sir, from the entire team of Civil Engineering Department, System Accounting College of Engineering. I request you, sir, to please take over the session.
Okay, sir. Thank you, sir. Good afternoon to all, guys. So, let's start for today's session. I hope you know what is the topic for the today's session is tension member, compression member, and if we have some, if we left some time, then we will see for the beam also. Okay. So let me share the screen. So today we will start about the discussion and some basic requirement of the tension member. As this is the steel structures in the last class, in the shortly I want to revise the previous discussion is because it is helpful for here also. In last class we have seen introduction about the working stress method, limit stress method, and some steel sections. Okay, so in that case, that is very necessary to understand which sections are suitable for particular conditions. For example, I want to design as a tension member, so I can't use any type of section, so particular section is required. But first, before going to design as a tension member, mostly if you know what you mean by tension, how the tension is generated in the structures. Okay, so today's first discussion topic is the tension member. So tension members means, it word gives meaning means that member will experience only a tension. There will be the no other type of forces or stresses will generate. It's purely tension in nature. There is no compression. Okay, at the time of design, only the consideration is this, only purely the tension member. Okay, no other stresses, no other type of forces will be there. So generally, the opposite force of the tension, if you are talking about the opposite direction of the tension, means the compression. So compressive force, compression is the opposite nature of the force. Okay, opposite nature. Okay, so we can discuss like that. We can say that a member, for example, this is a member. Please remember this word is very important. If this is the member, okay, if I want to design this member as a tension member, if I want to design this member as a tension member, guys, so obviously the tension forces means this member will try to extend. Okay, so assumption is what? There is only pure tension. There is only pure tension is available here. Compression is absent. No compressive force will be generated here. That was the assumption while the design of the tension member. Okay, so in such a cases, which type of member is suitable? That is also very important topic while the discussion. But as a designer, without analysis, can you able to determine which member goes in the tension? Okay, which member will experience the tension? So obviously, for example, this is the member having this is joints number 1 and joint number 2. If one forces, the forces is pulling this element, means this is the tension. Okay, this is the tension. In this plate, the tension force will generate. In this plate, the tension force will generate. That means this member will try to extend their in length. This member will try to extend in length. Okay, it is not like that. This is the single case. For example, this member is fixed at one end. For example, this is one member, and this is fixed at one end, and this is the force P. So as compared to this diagram, is this diagram is same? In this member, which type of force will generate? Obviously, in this member also, there will be the tension force will generate, because there is a fixed support and this is a pulling force. Okay, this force will try to extend the length of this member, and this is only one force acting at this end. So obviously, there will be the one opposite direction reaction will develop, which is also equals to P, total force. So obviously, this is also case of tension. Okay, so tension member design. Okay, if you want to understand the design of a tension member, you need to understand what is the tension forces, how the tension force will generate in the member. That is an important task. Okay, so today first we will see the tension member, then we will go for the compression member. So in this part we will see the introduction of what is the tension member. Introduction, what is the tension member? Just let's we continue, guys. Sorry for disturbance. So in this part, we will see what is the tension member, the introduction, the behavior of tension member under detention, plate, thread rods, angle under detention, which type of sections we can use in the section, and codal provisions for the tension member. Okay, which is the important part. Mostly in the gate examination, the question will comes on the sections, this part, and the codal provisions. Some mostly it will becomes from the section part and the beer plate under detention. Means behavior question will be mostly asked as compared to the codal provisions. So we will start. We'll see what is the tension member first. So here we have some examples I've tried to trying to explain you. Most favorable case for the tension member is in which pure retention will generate, that is truss. And truss is subjected to what? It should be a pin jointed truss. If any pin jointed truss is there, I hope you remembered your UG subjects. If there are the pin jointed truss is available, so in that pin jointed truss, mostly all the member will experience compression and tension only, because there is an assumption that all the forces will acting on the joints. Okay, so there will be the no member forces. So if there is no member forces means there will be the no shear force and bending moment in the structure. So this is the truss element. And if you see, this is the breast frame. This is the base frame. So means what? There are the bracings are provided in the frame diagonally, and this bracing should be a pin jointed only. Then only this bracing will experience the compression and tension both. Okay. I hope guys you understand what I mean by tension, compression, and truss. What is the difference between the truss and frame element? Okay. As if I want to explain that, for example, if you see if any member, this is one member, and that member is having the loading in throughout the member, means it will be deflect and it will experience the shear force and the bending moment. But if in this member, same member if you consider and apply the forces at the joints, so there will be the no shear force and bending moment, only tension or compression will experience. Okay, so whenever we are going to solve the compression or tension member, so you should remember there will be the no shear force and bending moment. Okay, and loading should be along the length of the member. Along the length of the member. Let's see. Yes, the member experience axial force, stretching, uniform stress over the cross section. The meaning of these three words are the same: axial force, stretching, uniform stress over the cross section. Obviously, guys, again I am drawing one plate. This is one plate. Okay, and this is the center axis of your plate. If your force is acting exactly at the center, okay, so this is called as axial force, which is acting along the major axis, or you can say the longitudinal axis. The force which is acting along the longitudinal axis of a member, it is called axial force. Okay, so if your member is having the axial forces, so it's the characteristic of member. So in the tension member, only axial forces will be there, but the axial forces should be a stretching in nature. Stretching means what? That forces will extend the length of the member. It should not reduce the length of the member. Okay, that is the properties of tension member. Such a question may be asked in the examples. The objective will become in any pattern. So let's see, there should not be this type of force. So its force should be in the stretching in nature. This is the second property. First property is axial force. Axial force means the force will exactly act along the longitudinal axis or the major axis of a member. Okay, that is the axial force. And second is the stretching, means it will be stretching the member, means it will be try to move, it will be try to increase the size of a member. Okay, next property is uniform stress over the cross section. Yes, if you measure the stress from this point to the end point, that means point number 1 to point number 2, you will observe that the stresses from point number 1 to the point number 2 will be uniform, because the value of the force will be same throughout the length. It will not going to change. So stresses throughout the length will be same. Okay, because in the both the direction we are applying the same amount of the force, then only we can experience the stretching. This is the stretching. Okay, so this is your tension test. If you remember, in the UG we have done the tension test in the strength of material, that UTM, on the UTM, universal testing machine, we have attached the member and we are stretching that member up to the failure. Okay, that is a tension. So next is it's a very efficient member. Yes, the strength governed by the material strength. Bolt hole affects the strength, obviously. If there are the two plates, for example, this is plate number 1, and I'm attaching another plate over this. like this. So I need to apply a bolting. So this bolt hold maybe reduce the strength. The bolt hole maybe reduce the strength. Okay. So in for the such a condition, it should not be affect the strength. The provisions for providing the bolt hole are given in IS 800. The provisions 800 is provided the provisions how to provide the bolting depending on the nature of the forces, that means amount of the forces and the size of member and the connection type. Okay, next. Yes, very important task is very important of is cross section used for the tension member. So angle section, if you use the same angle in the two times in, so double angle section for the larger forces. Channel section, I section, rod, cable. Okay, this is built up sections. These are the build up sections. Mostly I will tell you, if it is a trusses, if it is a trusses, so this two is preferred. This two is preferred in the trusses. Okay, this I section is very rarely used. Very rarely used this I section. If any examination, the question comes for in the trusses, which type of tension section, if for the tension section, which type of cross section is used. So you should mark if it's there angle section is confirmed is used in the truss sections. Okay. For example, and the channel section. In the channel section, generally used if any building is there and if you are connecting any tension member in diagonally, so in such a cases this two type of member will be used depending on the what type of forces is available, amount of forces. Okay, but whatever connection is here, that will be in the frame, particularly in the frame case. The connection of a diagonal member, if it is pin connection, so this will be considered as a tension member or the compression member depending on the direction of movement of the frame. If your frame is deflecting in this direction, so this member will exhibit tension. If your frame is deflecting in this direction, this member will behave as a compression. So in the compression member, mostly channel section are using, and in the tension section also this is used. Rod. This rod, if you know, we are using as a tension member. Okay, cables in the suspension bridges. In the suspension bridges, if you know, in the Nagpur near the railway station, there is one suspension bridge. If you see, the cables are used in that bridge. Okay, near the railway station. So that cable is called as tension member. It is also called as tie member. Tension member is nothing but a tie member. Sorry, tie member. It is another name is tie member. Okay, tension members of another name of a tension member is a tie member. Okay, so please remember whenever you will solve the truss problem, so preferably use angle sections. Next. Yes, the material property. So what this curve indicates, what this curve is indicates, okay. If you see in the mild steel and high strength steel, two curves is there in this graph. There are two curves. Okay. So generally, in the steel structure, you can use both the type of steels. You can use both these type of steels. Okay. But okay, but there should be This is this. If you see the mild steel, the strength of mild steel is this. The strength of mild steel is this, and the strength of uh, high strength steel is this. But there is not only the strength in terms of force. There one more strength is called delta, that is deformation strength. Deformation strength means ability to deform without collapse. Ability to deform without collapse. If you see, the deformation capacity is very important while design a steel structures. Okay, because mostly we are assuming we want to design our structure. Steel structure should be a ductile structure. Okay, ductile structure. Steel should be a ductile in nature. Okay, so this shows the material property of the steel. Okay, so mild steel and high strength steel, so both the steel we can use in the steel structure depending on the purpose and use. Next, so behavior and tension, this is the whole. Okay, so if you see, as according to theory, the stresses should be uniform throughout the length. Okay, so this is the plate. The force P, for example, is applied here. The force P is applied here. If you see the stresses along this plane is uniform because there is no change in this area, cross-sectional area. There is no change in the cross-sectional area, but due to some hole, this hole is provided for the bolt. So in that case, there is a nonlinear variation of the stress. The hole, the maximum stress is experienced. So therefore, whenever we are providing the hole to the plate, there is required to check this hole is suitable for that stress or not. So that check is also we have to done while designing the tension member. So we will see the provisions for the all the terms. Okay, so these are the cases how to calculate a net area if holes are provided in such a patterns. Okay, if you see case number 1, 2 holes is required, so both the holes are provided in one line, so net area will be given by this formula, and both holes are in not one line having some pitch, so net area will be given by simple this formula. So this is more effective than this. Then it is exactly in this fashion. There is another case is provided. Okay, so what is this indicating? That so your area should be is greater than and less than this. Case C is indicating, okay, in between that. So generally this type of connections we are using depending on the what amount of force is coming on the member. It is giving in the clause 6.3 IS 1893. So this is another way of providing the connections for the plates. This is the angle section. So what it's saying, generally this is your member, this is your member, and this is your plate, and this plate is connected to the another member, and this plate experience the tension, and this plate is connected to the member. So this is called as eccentrically loaded through gusset plate. This angle condition is eccentrically loaded gusset plate. So what are the design provisions? The most important thing, what are the design provisions provided in the uh, IS code, revised IS code, that is LSM, limit state method. Okay, So IS 189, IS 800 2007. Okay. So clause number is 6.1, tension member. 6.2, design strength due to yielding of gross section. Design strength due to yielding of gross section means the chances of failure due to yielding of cross section, the failure of your tension member. So design strength due to rupture at a critical section. Critical section means what? I already told you, we are providing hole, and at the edges of hole there are the critical section. So this design strength we have to calculate. So we need to calculate both the design strength. According to that, we need to design our section. Okay. So we will see tension member. So factor design T, tension T in the member, okay, the T should be less than design strength. Means what? This T is more, means external force coming on the member. For example, this is the member. Okay, the strength of this member is TD. The strength of this member is TD, and this is T, which is I am going to apply. Strength of member is TD, and T is a force which is I'm going to apply to the member. So what is the principle is that your TD should be more than T. Then only this member will be survive. Otherwise, this member will fail. Okay. So TD will be more than T. Next is design strength due to yielding of the cross section. The design strength of the member under the axial tension, that is TD, is given by. So what is meant by this TD? TD will be the least value of this two. Least value of this two. Okay, strength. So how to calculate the strength of your member? How to calculate the strength of your member? So strength of member will be calculated by these things. So this is Fy, means strength of material, yield strength of material. Ag is what? Gross cross-sectional area divided by factor of safety. Divided by factor of safety, which is standard value is given by 1.1. So if question is asked, as for the design of tension member, what is the factor of safety in case of yielding of gross section? Okay, so in that case, your factor of safety for that case should be 1.1. You have to show. Okay. Next is see what is this TD. I told you this TD is the least value of these two, 6.2 and 6.3. So design strength in tension of the plate, due to rupture of critical section means, I told you critical section means where the holes for bolting. So due to this, the critical section will create, and for there is one formula, TDN 0.9 FU by AN divided by FM1, gamma M1. It is factor of safety in this case, which is 1.25. So obviously I told you it is related to holes means AN. AN is a net area. Net area means you need to deduct the area of the holes because we are creating the area holes. So area of the holes will be minus. So how to minus the area of the holes? The formula is given for the AN. By using this formula, you need to minus the area of the holes. That will be the net area. And Fu is the ultimate strength of the member plate. Okay, material of your plate, tension member. So very basic concept while designing is what? The strength of plate should be more than the applied force. So what is the strength of member is less than least value of this two. Least value of this two. So the thread strength. How to calculate the TDL? This AN value. So it is related to thread. So by deducting this value of what is your bolt area hole, bolt hole, you will get this TDN. Okay. So for the particular angle section, single angle section, the formula of TDN is provided in the code. Okay. So this is the one of the type of section, angle section with end connections. So how the angle section is connected? This is bolt. This is bolt connection, and this is weld connection. So there are the welding in these two edges, and this is the bolting. So this is the hole made in the angle section. So due to reduction in this area, there will be the effect in the tension. Okay. So design strength due to block shear means what does we need to check the block shear strength for the connection depending on which type of connections we are providing. So there are two values of TDB. You have to calculate these two. Okay. So we will see the formulas for this also. I will show you the formulas. So design strength of tension member. Just now we have seen that is yielding of the cross section, yielding of the cross section, yielding of the cross sections. Then the strength, critical strength. Okay. Then block shear. These three things we need to check, and all those three things will be, these two will be greater than applied given load. Okay. The formula again I applied here. So it is required to remember the safety factors, partial safety factor for the failure of partial safety factor for the failure of tension by yielding. Okay. Then for the critical section, these are the TDN formulas given. How to calculate the TDN here. So if this is the single angle section, if I told you the bolt is connected for the single angle, so in that case, an effectiveness of outstanding length is governed by the rupture at the net section is given by. So your TDN formula will slightly change. Your TDN formula is slightly changed. There is one unknown term is included, that is beta, constant term, and the beta is given by this formula. Here your beta is given by this formula. So here ANC is the net area of the connected leg, means area of the connected leg, and gross area of outstanding leg. Outstanding leg means which is not connected to the plate. If you see, this is the outstanding length and this is the connected leg. Okay. And for the other sections, this is the block shear check for particular problem. So you need to calculate these two values. These two values. In this two value, there will be the AVG, AVN. This is the minimum gross and net area in a share. Okay, and minimum gross and net area in tension. So, share area and tension area that is required to calculate these two strengths. This is the check. This check should be the block shear strength. You should so the strength of your plate should be the minimum of these two values. The strength of plate will be minimum of these two values we need to consider. That is, we can say the smallest value. Smallest value. Here also I have written the smallest value. So this is the tension member provisions, whatever I have given here. I hope this is the sufficient task for the tension member. If you want, I will take one example on the tension member also, how it is solved. So if you see, there is a design example of a tension member. Design example of a tension member. Design example of a single angle section. There is the question, a very simple question. We will take in 2 minutes first. Design a single angle section for the tension member roof truss. Carry the factor tensile force of this much. Okay. So let's given data is there. So grade of the steel we are using Fu is equals to the Fi is equals to this. So partial safety factor already we have discussed. So from the consideration, the yield strength, gross area of the angle is required. So gross area, this is the force is given. This is the stress value with the shifter safety factor, and this is the area. Depending on this area, we need to select the section. So here I have selected the section that ISA 1075. Okay, that means 100 by 75 by 8 mm, which has the gross area is equals to AG 1300. It should be more than this value. So you can take anything, anyone. So use the gusset plate of 10 mm. That is the assumption. So I told you there is the steps to calculate a strength. So this is the bolt strength we have calculated. Depending on the bolt strength, we got number of bolts here. So this is the number of bolt 5. So 5 bolts are connected in line. This is your angle section. So as I told you, you need to check your design by calculating the strength against yielding, strength against rupture. Okay. So this is the AG, gross area, Fy, safety factor, and this is. So what is this? This is TD, which is greater than T. So okay, satisfied. Okay. Similarly, strength of plate in rupture. So I told you there is one formula is given like this. So by applying this formula again, TDN you need to calculate. So this TDN is also should be greater than T, and that T is I think 250. So 250, 225. So let's check it is coming greater than and that or not. Yes, it is greater than 225. So again, this design is safe. After this, there is strength against block shear is required. So for calculating the strength against block shear, we need to gross shear area. This is net shear area. This is gross tension area, and this is net tension area. So after putting this, we are getting these two values, and list of these two, this is the list value, and this list value should be greater than T. This is T. This is also satisfied. Hence, safe. Design is safe. So likewise, we need to check for the tension members. So after this, we will try to see what is the compression members. What are the compression members? So generally, the compression member means the member which experience the compressive force. Okay. So here the structural member subjected to axial compression force. Okay, means purely axially compression, opposite to tension. The design governed by the strength and buckling. Here there not be rupture, there will be the buckling. The column are subjected to axial loads through the centroid. The stress in the column section can be calculated by P by A. That is pure strength because the force only is the compressive force. The failure mode of an axially loaded column is local buckling, okay, overall flexural buckling, torsional buckling. So this is the type of failure occurred in the compression members. So I hope there is not much of the explanation of compression member because already we have taken a tension member expressions already. So you can see this is arch ribs, rigid frame members inclined, okay, compression member element in the truss. So this is the more favorable cases which is generally occurred many times, okay, which is generally occurred many times, which is rigid frame inclined and a compression member in the truss. Rigid frame inclined means what? Just now we have seen one example of tension member. So this is inclined. So whenever this frame is moving in this direction, this member will experience the compression force. So there are the examples of the compression member. Obviously, this is the column, arches. That is roof arches. There is also, this is the truss problem. So some member will be compression, some member will be tension. For example, this is the truss. If there is one vertical force is there, is there any vertical force like this? Sorry, here it is a vertical. It's not able. So this member will experience the compression. So I'm showing some images for the truss members, which includes compression and tension, both the members. So this is some condition for elastic buckling of the slender compression member. Okay. So this is the buckling conditions. So whenever your force is exactly at the center of your member, there will be the chances of buckling. And this is the example of buckling showing in the diagram. Okay. So slenderness ratio L by R. R is the radius of gyration, L is the length. So it's a slenderness ratio. The longer column for the same X section, greater become its tendency to be buckle and the smaller becomes its load carrying capacity. Okay, if your length is large, it is more chances of buckling and smaller in the load carrying capacity. So your length should be restricted. Okay, so how it is restricted? There is a provisions is given by a slenderness ratio. Okay, so R is what? Radius of gyration, which is calculated by root I by A. I is a moment of inertia, A is a cross-sectional area. The tendency of a column to buckle is usually measured by the slenderness ratio. So IS code, the slenderness ratio, the range is provided. According to that range, we have to provide a column. Okay, so slight there is the effect. There's the effect of material. Okay, obviously the effect of material will be there in the compression member because as it is compression member versus tension member, there will be there will be not large effect on the compression member due to the material. Okay, same behavior we can see in the both the cases. See here, major difference. Tension member, in the tension member cause lengthening of the member. Lengthening means increase in the length. Increase in the length. Here, compression beside compression force causes buckling of the member. Buckling means you can say you are going to buckle, you are reducing the length of the member. You are reducing the length of the member. Okay, this is the lengthening of the member, means the stretching, linear stretching. The presence of a hole in the bolted connection reduce the gross area in the tension member. The presence of bolt is also contribute in the taking the load. Okay, that is net area is equals to gross area. See guys, here very important parameter, presence of hold will affect the tension strength of the member in the tension, but in the compression bolt will also contribute the strength in the member. That's why there will be the no effect of the bolt in the compression member, because bolt is also contributing in the compression. Okay, so bolt is not much affecting the strength in the compression member, but in the tension member bolt hole or may affects the strength. Okay, that's why here there's a reduce in the gross area. So net area here, an will be not equals to ag. Here assumption is an is equals to az. An means net area, ag is gross area, actual area. Why column are more critical than the tension member? Column is the more critical than the beam or the tension member because minor imperfection in the material and dimension means the great deal, means there will be the great loss, because column is a member which is resisting the beam or the tension. Therefore, a compression member is very, very important. We'll skip this. Excuse me though. I want to show here. I want to show you one small example regarding to single angle compression member. Single angle compression member. How we are designing, which formulas we are using. Design a single angle discontinuous strut. Strut is another name of a compression member. Compression member is also called as strut member. Compression member is also known as strut member. So if anytime the strut member is word is coming, so it is compression member. So factor axial compression load is 65 kilonewton. Okay, and the gusset plate thickness is provided 12 mm by 20 mm diameter bolt also given. So here initially tentative area we have calculated. Tentative area, how we are calculating tentative area, I told you the section will be decided on slenderness ratio. Let us assume the slenderness ratio is 120. Corresponding the slenderness ratio KL by R 120. From the table, the design's compressive strength is coming this much. Design compressive strength will be based on a length, slenderness ratio. It is not exactly same whatever we have. It will not same because this will be tested under the tension. Therefore, the actual compressive stress for particular member corresponding to this material, we need to find out by the slenderness ratio. So here generally just we are assuming the slenderness ratio because now we don't have a dimensions of the section. So we assume 120 as a slenderness ratio. Okay, and for that slenderness ratio, so table is given in the IS 800. From that you can get a design strength, and force divided by design strength will give you the required area. This is required area. So your provided area will be more than the required area. This is required area. The word is written here, required area. So for based on this area, we tried. So ISA 70 by 70 by 8 equal angle section, 70 70 equal, from IS handbook number 1. So rival property for this section is area is this. So area is more. Yes, area is more than this. And radius of gyration is 13.5. For this case, effective length is 3 meter. So number of bolt is calculated by calculating the bolt strength. This is another part of discussion, how to calculate a bolt strength. So bolt strength we are calculating. So finally we are getting the strength of bolt is 45. So coming for 665. So to resist 65, nearly 2 bolts will be required because each bolt having 45 strength. So the coming force is more than 45. Therefore, 2 bolts are required. For these 2 bolts, okay, for these 2 bolts, we have calculate the imperfection factor. There is a formulation for calculation of the imperfection factor. Okay. So here, the design compressive strength, again we are recalculated that 64.81, and the design compressive strength, this is the stress. The strength will be area into stress will be the strength. So gross area into the stress will be the strength, and this should be greater than 65. If it is less than 65 means your member is failed. This force is coming more than 65 means it is passed. So this is the compression member. So compression member will fails under the compression, buckling. And if you are talking about the tension member, so failure of the tension member will be occurred due to what? The failure of the tension member will be occurred due to yielding of the cross section. Please remember this word. And rupture strength of the critical section and block shear. These are the failure pattern of the tension member. And for the pure compression member will be failure under buckling. So that's why we are calculated here the design strength. What is the strength of compressive strength of material or section I have provided? That strength should be more than the applied coming force. Okay, so this is the small difference between a tension member and the compression member. Okay, so failure pattern of the compression member is this 3: yielding of the cross section strength of critical section, and block shear. These are the 3 types of failure pattern in the compression member. So in short, we will see the beam member also. Design of beam. What do I mean by beam? The horizontal member seen in the structure spanning, the horizontal member, the spanning between the 2 columns is nothing but a beam. generally we are calculating the support loads which are resisted by the bending and the shear. Yes, obviously this is the bend member, so bending and shear will become the supports floors, roof sheeting as upper links, side cladding. This is also a type of a beam in the steel structures. Beams we are using as a floor beams. This is the girders. The big size of beams we have floor beams is called buildings is called as girders. Lintel beams, purlins, which is used in the truss, rafters. This is also used in the truss sections. Okay, the splendor beams, which is also used in the outermost wall of the buildings. Then stringer beams. This is the longitudinal beams used in the bridges, floors, subjected to the by the floor beams. So, sorry guys. So beam also we have a type of beam. So in which pattern the beam will be failed. So we will see this beam. So what in that case, generally while we are going to design a beam, most important the beam will fail under the shear. Okay, check for the shear, check for high and low shear. Okay, then check for bending strength. Okay, because in the beam and check for the web buckling at the support. Okay, generally how many types of failures will the beam will be occurred? How many type of failures? The failure of beam will be occurred due to a shear, because for example this is one beam which is simply supported. First case I will consider as a simply supported, and I am applying the UDL here. Obviously this beam will experience a shear force. I hope this is the shear force diagram for the beam, and the bending moment. Okay, so you need to check for the shear, you need to check for the bending moment. So there will be a check for shear in the beam case. So only in the examination, mostly if they are talking about the beam, they will ask you which is the type of failure in the beam. Okay, causes of failure, type of failure. So this is the shear failure. Okay, then check for high and low shear and a bending strength. That means failure due to flexure and bending. It is also called as flexure and bending. So failure due to bending. So you need to check for the bending strength also. So whatever bending strength for your particular member should be a more than the bending moment generated. So this this bending moment should be more than loading bending moment. So this is the strength of your member. This is the bending moment generated due to loading. Okay. So in this, due to this relation, we will say that our member is safe in the bending. Our member is safe in the bending. Here also, this is the strength of your member. Strength of member is 340, and this is the shear force due to loading. Means your member is safe in the loading shear force also. Similarly, we need to check for the wave buckling at the support, because at the support there are the maximum shear. At the support there are the maximum shear, so there may be chances of buckling in the wave, because in the beam element we are using I section. So there may be the chances of buckling this member, because at the support there is a maximum shear. Okay, so you need to check for the wave buckling at the support. web buckling and the support. Please remember these three words: check for shear, check for bending strength, and check for web buckle. Again, I am repeating the failure pattern for the steel tension member is failure due to yielding cross section, failure due to critical section, and block shear. This is the failure for the tension member. In the compression member, there will be the failure due to buckling and crushing. And in the beam case, there is the failure of the web buckling, failure of the due to the bending strength and the shear strength. Okay, shear failure, flexure failure, and buckling failure at the support. So these are the discussion regarding today's discussion regarding what your member sizes and your member sizes, the section tension member, compression member, and the beam. So I hope this is sufficient for today's discussion, because while designing the compression column and beam column connections, they takes more 1 hour. So I hope you understand. If you have any questions, so you can ask now. Otherwise, I will stop here.
Thank you very much, sir. Students, if you are having any doubt, you can ask now. The session is open for question answers. If any one of you is having any question, please you may ask. Okay, the sir, the students are saying that they are not having any doubt. They have understood each and everything.
Okay. Okay, sir. Okay.
Okay, so on behalf of the entire department, Civil Engineering Department of Tulsiramji Gaikwad Patil College, I would like to thank you, sir. Thank you very much for sparing some time from your busy schedule and giving an insight knowledge of this subject to our students. Thank you very much, sir.
Thank you, sir.
So now, sir, I will take the attendance.
Okay, I will leave it.
Okay, you can leave the class. Thank you very much, sir.